Welcome back. In this video, we're going to be doing the Embedded Assessment 2 that follows after Embedded Assessment 3 that follows after Activity 15. Till now, in my previous videos, we had done the basics of linear equation, Activity 10, 11, 12, 13, 14, and 15 from SpringBoard Course 3. So let's start with Embedded Assessment 2. The Embedded Assessment will test your elimination and substitution method skills and the graphing numerical method skills. So let's get started. The title of this Embedded Assessment is Solving Systems of Linear Equation, Supply and Demand. So let's read this problem situation before starting. It says, when something is popular and many people need or want to buy it, the price goes up. The item that no one wants are marked down to a lower price. The change in an item's price and the amount available to buy are the basics of the concept of supply and demand in economics. Demand is the number of things people are willing to buy at a particular price. Supply refers to the number of things the manufacturer is willing to make at a particular price. The price that the customer pays is based on both supply and demand. Suppose that during a 6-month period, the supply and demand for a popular gaming system in a certain city has been tracked, and approximately by the following system of equations, where x represents the number of gaming systems in thousands and y represents the price per gaming system. So these are two equations. One is for demand. The demand equation is 0.7x plus y equals 340, and the supply equation is negative 1.5x plus y equals 320. So the problem states in economics there exists two terms, supply and demand, and there exist two entities, manufacturer and consumer. How entities mentioned above link with the above economic term? So demand refers to the number of things the consumers are willing to buy at a particular price, and the supply refers to the number of things the manufacturer are willing to make at a particular price. Price the customer pays is based on supply and demand, or demand and supply, any way you want to say. In the problem, supply and demand for a particular gaming system is mentioned below. So X is the number of gaming systems in thousands, and Y is the price per gaming system. So let's model the situation. So since it's a demand and supply equation, let's make them into a system of equations. So let's do 0.7x plus y equals 340 and negative 1.5x plus y equals 320. So, and then basically let's isolate this into slope-intercept format, and then for this we get slope-intercept format. Y equals 340 subtract 0.7x, and then let's write this equation as it is, negative 1.5x plus y equals 320. And then since we can use substitution method to substitute in this part of the equation over here, because y equal each other, so let's do that. We get 1.5x plus 340 subtract 0.7x, which equals 320. So this equals 320. And then we combine the like terms. So that like terms combine to negative 2.2x. And then we subtract 340 from both sides. And then that gives us negative 20. So then we divide by negative 2.2 on both sides because we're multiplying by 2.2 over here. So we get x equals 200 divided by 22. So then this simplifies to x is equivalent to, I'm going to round to the 10th place, 9.1. So, and then this is so for number one. So this is the solution for number one. Number one says solve the system algebraically to determine the balance point between the supply and demand. So we solve this and we determine the balance point. And then let's solve for y too. Y. So then we know. So to solve for y, we put in the x in the equation. So I'm gonna put an x in this equation because it's the first equation I see. So 0.7x plus y equals 340. And then we found the answer to number one. So let's write the answer right here first. And then let's draw a line here so we don't get confused with the other questions' answers. And let's say number one. So the answer we found was to the question, solve the system algebraically, basically using substitution that we did to determine the balance point between the supply and demand. So we found the balance point, which is 9.1. So number two says, at about what price do the supply and demand balance? So number two, and we know that we did solve for y because it says over here that y is the price per gaming. So we had to talk about the price. So let's take the equation for demand first. So the equation for demand is 0.7x plus y equals 340. So let's write that, and then we'll find the price to demand, and then we'll find the price to supply, and let's see our answer. So let's write my let's write my equation for demand. And then I'll just sub in my x value, which I found in the previous question over here. So then I'll get 0.7 times 9.1 plus y equals 340. And let me just write demand here so we don't get confused with the demand and supplies equation. So, and then this will equal us 6.37 plus y equals 340. And then we subtract 6.37 from both sides. And then we get y equals $333.60. And since price is in dollars, we have to add the units. Plus we have to add our hundredths place, and so this is our price for demand. So let's see our price for supply. So let's write the supplies equation first. Negative 1.5 x plus y equals 320, and then we do this and we substitute in the x value in the x place, and let's write supply here so we don't get confused. So negative 1.5 times 9.1 plus y equals 320. And then this gives us negative 13.65 plus y equals 320. And then we add 13.65 to 13.65. And then we get y equals 333.65, and then since these are both abouts, so since this is about, I'm gonna round this down, so I'll get y is approximate to $333.60. So as we see, since these both are the same, we get the supply rate of $333.60. So let's write that at what price is supply and balance. So that's $333.60. So this is our number two. So let's make a line here so we don't get confused with this. So let's solve number three. Number three says, about how many gaming systems is the manufacturer willing to supply at that price? So we found out, this is not in thousands, that this many gaming they're trying to find. So first, our problem is that we have to convert this into thousands. How do we do that? So we times this by 1,000, and we do that because x represents the number of gaming systems in thousands. So we have to times this by thousands to get the answer to number three. So we do 9.1 times 1,000, which gives us 9,100. It's approximate, so that's how many gaming systems the manufacturer is willing to supply. So 9,100 gaming systems. So since I have solved number 1, 2, and 3, and you guys have practiced with this, let's move on to the next scenario. Next scenario says, during the same 6-month period in a different city, the supply and demand for the same gaming system is represented by the following system equations. So this is a demands equation, this is supplies equation. Number 4 says, solve the system by graphing to determine the balance point between supply and demand in the city. Well, we solved this algebraically, and you can solve this by graphing by creating a table of values and then plotting the data. So I'm not gonna go over this because we have done a lot of graphing, and this is kind of similar to number 1. So let's read number 5. Number 5 is, at about what price is supply and demand balance? Well, that's the same exact question number 2. So you guys can do number 5 on your own since I already have gone through number 2 with you guys. So let's go to number 6. Number 6 is, about how many gaming systems is the manufacturer willing to supply at that price? So this is the exact same question as number 3. So I went through number 3 with you guys. I'm pretty sure you guys can do number 6. So let's move on from page 199 under assessment 2, that's after activity 15, to page 200, the embedded assessment 3, use after activity 15. So it's a continuation of the same but embedded assessment. So let's read this problem scenario before starting. It says the manufacturer will supply gaming systems to a third city based on the supply equation shown below. So this is the supply equation for the first city. This is supply equation for third city. So it's the first 2 cities and third city. So let's read number 7. Number 7 says, at what price will the manufacturer supply all 3 cities with the same number of gaming systems? You may solve either algebraically or graphically. Show all your work and explain your response. Well, we had a lot of practice with solving systems algebraically and graphically, so I'm pretty sure you guys can do this on your own. And thank you. In this system of equations, you have to solve for y because y is the price. As we know on the previous page, page 199, it says over here that y represents the price. So that's why in the in number 7, we have to solve for y, which is over here. And thank you for watching this video.